Yeah, can I?
Take over.
All right, great. Thank you. Give me a couple seconds. All right. You guys can see my screen, right?
Yep.
All right, perfect. So, first of all, thank you so much, Shashanka, for giving me the possibility to present the work that we have been doing at DefinedCrowd with DataHub. For everyone else, my name is Pedro Silva. I'm a data engineer at DefinedCrowd. So first of all, let me just very briefly explain to you what the company is. Essentially, we are a marketplace for AI data, and our objective is to make your AI use cases smarter. And the way that we do that is by crowdsourcing data assets specific to your use case and to your industry as a service with certain quality guarantees. These can be things like speech to text, translations, audio, or even image recognition type data assets. Regarding the company, we were founded in 2015. We have over 300 employees. And through our Series A and Series B funding, we have over $63 million already raised. Important to mention in this talk is that one of the ways, or the way in which we crowdsource data sets is through our Nevo platform. This is essentially a mobile application for Android or iPhone, where regular users can download the app and earn a little bit of money by performing certain tasks. These tasks are what we call as units of work. And to give you a sense of the statistics and the scale with which we work, it's over 1 million units processed per day with 500,000 or more crowd members and growing over 70 countries and speaking more than 50 languages. And the reason that this is important is to give you a little bit of context with regards to the data ecosystem that we have at DefinedCrowd. Essentially, it's an event-based data lake-like system managed by a centralized and specialized data engineering team. And the purpose is for reports generation, dashboards for the multiple teams that are allocated to certain projects, and also to help perform our internal quality control over the crowdsourced data assets. Regarding the architecture itself, what we have is Nevo generates certain metadata events. So let's suppose that a certain unit of work has been assigned to a user. He has been working on it, so you have progress over time. It can be canceled, it can be completed, these sort of things. So a sort of state machine of events based on multiple aspects of the platform is the input or is the source of data for our platform. This is then retrieved from a Kafka log storage, where we can perform a number of things. One of which is through KSQL perform streaming joins. And the reason that we want this is to have a real-time computed view over certain data views, if you will, on our data. And that is stored back into Kafka, which through Kafka Connect, we store in HDFS. Internally at DefinedCrowd, we use, or our cloud is Azure, and we do use certain managed services, including, for instance, Azure Data Factory, which is Azure's managed offering of something like Airflow. It's their own interpretation of that. We also have the typical ETL batch-like processing, in this case through Spark, where we take raw data and process our Kafka topics into usually views that are more consumable for our stakeholders. And these views can either be consumed via Druid or via Hive. The use case here is in Druid, we want to work with more real-time queries and an SQL-like approach. But in Hive, through DataHub, for those cases, for example, data scientists, where they want to perform actual manipulations on the data and they want to perhaps do some data cleaning and feature engineering for our internal machine learning models. So in a very high level overview, this is what we have for a data ecosystem. This is not everything, but it's what I feel is relevant to this conversation right now. And as you can tell, this is a very centralized like approach, and the whole architecture itself is owned and managed by the data engineering team. Our vision is to move towards a more data mesh like approach, which certainly has some benefits. for us, concretely, what we want is to achieve three things: data democratization, so allowing data-driven decision-making without bottlenecks or external dependencies by our stakeholders. These can be people like project managers, business analysts, so on and so forth, or even C-level decisions. We want them to be able to make those decisions based on data, but not being dependent on the team. And the reason being is that the scale of the team, the people who manage this infrastructure, we are around 6 people. This changes over time because we have people being allocated into different projects. But our fan out ratio, if you will, is 6 to 80. So if you want to reduce this, I think it's something like 1 to 12. That's sort of how it works. And given this scale, we naturally want our users to be more self-serviceable. So to do that, we need to provide intuitive tooling for them to be autonomous. And finally, this will allow then the data engineering team to scale up and be able to work on other challenges. Speaking of intuitive tooling, that's where DataHub itself comes in, right? Self-serviceability is something that's not really possible without having data discovery and data lineage over the assets that we have. And even for the data team, for us, we do increasingly have a harder time keeping up with the growth of data assets. Given that the company itself is a data provider, our asset catalog is continuously growing. And for 6 people, it's a lot of information for us to handle. So we needed a data catalog. From an exploration of the current ecosystem perspective, we explored options like WeWorks Marquez, Apache Atlas, Lyft, and Muton, mainly because they're open source solutions, and we wanted to understand and wanted to be able to contribute back in case their approach was not perfectly fit to the DefinedCrowd use case. Though we did also look to inspiration at companies like Netflix and Intuit that had other approaches. In the end, though, we did decide to go to DataHub. The reason being its extremely active community, the ability to have strongly typed dynamic metadata models. So being able to define certain entities, relationships, and being able to modify that, if possible, to make it match our use case. And finally, a push and pull ingestion model for the metadata, because we do have certain components of our architecture which are streaming based and others are batch based. Possibly some will be created by us internally, and having that flexibility is very important to us. To give you a sense of where we are right now, we've undergone the exploration, proof of concept based deployment. We are now at a production level deployment, though with a very basic use case. In this scenario, dataset catalogs only, and on our downstream databases, Druid and Hive. And the reason why we wanted to do this is to ensure that our direct stakeholders had access to information that they could understand. If they work with Superset and Jupyter Hub, they are directly interacting with data that's available and queryable in Druid and Hive. This was a work that involved 3 people, and overall, it was an extremely positive experience. Our initial rollout had over 20 plus data users, and their feedback has been quite good. Though at this time, because of a lack of metrics, I can't really tell you if this number has changed over time, but it is the information that we have right now. But finally, DataHub as a system, it is relatively complex, right? It's a largish database with a lot of moving parts, but the community support has been exceptional. So in that sense, I feel it has been an excellent choice on our part. Regarding contributions, and I know Shashank already mentioned this, we did contribute with some things, particularly monitoring metrics, crawling support for metadata, all of this done in Kubernetes because that is our default deployment mode, and finally support for Druid. Though it is not the end of contributions, I hope, but we will see as time moves on. So just to give you a sense, this is the ecosystem that we had before, and this is what we have additionally with DataHub, right? You have your DataHub UI, your installation. This is all done in Kubernetes. Then through the DataHub metadata crawlers, And the cron jobs, we query Hive and Druid. And finally, with regards to opportunities, we feel naturally there are things to improve. There always are in good projects. And in our case, for our use case, it's dynamic metadata models. It is true that these models are flexible and that you can change. However, they are hard-coded into the database in the sense that if we wanted to change, we needed to maintain a fork of the project continuously and from time to time merge things from the original repository to gain all the niceties and all the features that have been released. And the reason we want to do this is not all our data stakeholders are tech savvy, right? Some of them come from linguistics backgrounds with little to no CS training, and for them, semantics matters. For instance, quality control at DefinedCrowd for translation use cases involves having people who are naturally linguists. And they do not have CS training, and as such, we need to make their usability of this tool as intuitive as possible. Other things include role-based access control. So having granular entity level access definitions is something that I feel is quite important. So being able to say that a given data user has access to data sets A, B, and C, but not D, E, and F. This is something that is very relevant to us. And finally, field level lineage based on jobs and pipelines. So because we have certain data sets, or in a sense, certain views, where a subset of those columns are generated by job A and the others are by job B, this is the sort of information that we want to make sure we surface correctly. Though I do have to mention that all of this is already in DataHub's backlog. So I don't think that I'm saying anything new here, Shashanka, but it's just what we at DefinedCrowd would like to see in the future. And yeah, I guess that's it. I don't know if anyone has any questions. I do apologize if I sped through this presentation, but give me your feedback if you have any. Thank you so much.
Cool. Thanks a lot, Pedro. Definitely +1 on all the pain you felt with some of those things, especially the metadata models. We feel it every time we add one small thing to it. So yeah. No code metadata models are absolutely top of mind for us and are back also on the roadmap. Field level lineage also, we've got the RFC in, and so we'll figure out the implementation pretty soon. I had one question for you, Pedro, and then we can do some quick questions from the community. You currently have DataHub kind of crawling your Druid and Hive clusters. You also have some Kafka Connect in your ecosystem.
Yes.
Do you anticipate kind of pushing metadata from that streaming ecosystem into DataHub in the future?
Ideally, yes. I do feel that Kafka Connect's integration is more on the level of lineage than generating metadata assets themselves. So right now, as I understand it, the ingestion framework will generate data set snapshots and possibly even user information for LDAP systems. I feel that it needs to be adapted to be able to provide these sort of connections or updates to aspects of metadata, right? Kafka Connect feels very much like a source of that type of metadata. And at the ingestion framework level, we don't yet have that, as far as I know. But yes,
yeah, I think
it'd be definitely a +1.
Agreed. I think especially the way in which we've done the Airflow lineage integration, we can probably use the same strategy for Kafka Connect, where there's like framework level integration with Kafka Connect, and when those pipelines start up, they emit metadata events that then connect the edges together. Yeah. So that I think would be great for the community as well. Are there any other questions? We have a minute. You can always drop questions if you have them offline on the chat, and I'll try to get back to them towards the end. Right. Cool. Thanks a lot, Pedro. No and worries. Best of luck.
All right. Thank you so much.
All right. So for our next piece, we have